Alright, in this video we're going to jump right into getting our VRFs configured. And one of the statements that I have in our scenario is ensure VR configurations will support IPv6 growth natively. Now, when you're dealing with VRFs, there's two ways you can do this. You can do IPVRF, which is going to be straight IPv4, or you can do VRF definition and then specify the address families you want to activate it for. And then by doing that, when you type in the address family, that's going to be the address family that's going to allow forwarding for. So if you type in just address family IPv4, that means that only IPv4 is going to work. If you do IPv4 and IPv6, then you'll be able to do a dual stack. So eventually we will get down to that, but that's going to be down the road a bit. So we're going to start on router 6 like we've been, and what we're going to do is we're going to get everything operational with VRFs. So the kicker with, let me bring this over here so you guys can see this. So the thing with this, we have two interfaces, two different VRFs. So we have VRF red, which is going to be for OSPF, and we have VRF blue, which is going to be for RIP. We have the same route distinguisher and we have the same route target for both, but it's the import and export rules are going to be the same. So it's basically going to be everybody's going to be able to talk to everybody. So that's going to be one of the things it says down here. It says all sites must have reachability over MPLS to all other sites. So that's going to be the one scenario caveat. So first thing we're going to do is we're going to get out of router here and get out of the router here. So the first thing we're going to do is we're going to type in VRF definition. So if you see any type of IPv6 with MPLS, automatically think VRF definition. So VRF definition, and then the now by default on most of the routers that I've ever been on that I've had to configure MPLS on, which has only been 2 in production, and they were both ASR 1000s, which is basically the physical version of the CSR 1000V. I don't remember if they had that or not, but I think they did. But anyway, we're going to type in, the first one we're going to work on is OSPF. So we're going to type in VRF definition red, and we're going to question mark, we're going to hit enter. Now we're in VRF configuration mode. Now what we're going to do, and this is where it gets a little tricky with how you set this stuff up. Now we're dealing with VPNv4 and IPv4. So we notice that we have route target here and RD here. Now we're not going to be doing IPv6 here, so we could sort of get away with doing address family, but we're not doing multi-address family in BGP. So I'm going to err on the side of caution here, and the reason why I'm doing that is because if you look, if we do show run pipe section BGP, I'm not in IPv4 address family VP, or I'm not in address family IPv4 unicast with BGP. I'm in what I consider to be non-multi-address family, meaning I don't type in address family IPv4 unicast and then start punching in my neighbor statements. I'm in the what I would consider to be the global BGP process, and not an address family specific. So therefore, for my VRF configuration, I'm not going to go into the address family and get specific because I'm not doing that. What I am going to do is I'm going to type in RD is going to be 2:2.20, which I believe is supported, and it is. And then we're going to type in colon is 65,000. Now the reason why I'm typing it that way is because all sites, so all customer sites are 2.20 because we're using a 4-byte autonomous system number, and the provider's BGP autonomous system number is 65,000. So we're going to hit enter. I guess that doesn't work. Thought it would. Unrecognized command. I guess you can't do that. So you know what we're going to do? I'm going to call an audible. And what I'm going to do is, well, I don't want to change. When we get into load balancing VPNs and things like that, I'm going to make the route distinguisher, because normally what you would do is you would set it up with the IP address and then the autonomous system number, or the actual distinguishing piece of it. I'm I'm going to do the router ID of the router. So in this case, it'd be 100, 10, 100, 11, 11 for router 11. So it'd be 10, 100, 11, 11 colon 65,000 to make it unique. So what we're going to do is we're going to type in, we'll type in 220. So we keep the same format, so the same numbers, colon 65,000. And that'll do. And then what we're going to do is we're going to type in route target, and we're going to say both is going to be the same thing. So we're going to type in, just copy and paste this. And hit enter. So that's all we have to do there. So I'm actually going to take this and I'm going to 220 and 220 there. So I'm just going to copy and paste this information in. Do a copy and place there and replace there and replace there. So there you guys go. It's up to date. I will be putting this out online so you can download it and try it out for yourselves. So that's how we're going to set this up right there. So now we've got the VRF configured. So now we're going to exit out of here, and we're also going to type in VRF definition is going to be blue, which is going to be for RIP. Hit enter. And we're going to type in RD is going to be the same as this guy. And then the route 220 is already in use by VRF red. Okay. Oh, you know why? That's because of the fact that they're different. See, this is why we do these labs. I didn't realize I couldn't do that because we have different. VRF is technically a different customer. Alright, so let me think about this for a second. Alright, so what I'm going to do is I'm going to change the 220 out to be 65. So it'll be 65 colon 65,000. And the reason why I'm doing that is because of the fact that the link that it's connected to is 65, so it'll be a distinguishing factor. And then the route target will be, see if this will take. It shouldn't matter on that. Because, yeah, the route target just indicates what PE is going to let routes come and go from it. The route distinguisher makes the routes unique. So, there was also a comment that I was kind of ignoring, but it's actually applicable now, where for every VRF you have is technically a different customer, which is technically true. But apparently a lot of providers will do a different route distinguisher per VRF, or sorry, not per PE router. So, technically speaking, when you are a customer, you're gonna, if you're going to do MPLS, the provider is going to give you a route distinguisher to make your routes unique, which allows you to route whatever IP addressing scheme you want over their network and never have to worry about it overlapping with somebody else's addressing scheme. These are different routing tables. So in this case, we're okay. I would say we're okay, and we're just going to go from there. But the route distinguishers can be unique, or will be unique, but the route targets will be able to pull routes in. So I think we'll be okay, and especially when we start getting into having different route distinguishers and stuff like that, it'll make it kind of interesting. So we're going to have that. So now we got this stuff set up on router 6. So the very first thing I'm going to do now is I'm going to exit out of here. I'm going to do a show VRF definition. A show VRF. Now, if you notice right here, we have the, some of the breakdown commands, or we have the specifics to red and blue. Right. So we have that stuff set up there. So now what we get to do is we get to apply this to the interface. So we're going to type in, go to global config, type in interface gig 1.46. I think that's what number I gave it. Do show IP interface brief. Yeah. So we're going to type in do show run interface gig 1.46. And I'm going to type in VRF forwarding. Now you have to, whether you're running IPVRF or VRF definition, you apply it using the same command. And we're going to say, in this case, we're going to type in red. And then it's going to take the configuration off. And I totally forgot to do the commands. I even checked before I did this. It's actually it's not supposed to. I can't do it right at the moment. So At least I have the show run commands, which is good. So I'm going to type in VRF definition red, and type in address family IPv4, and do the same thing with blue. And interface gig 1.46. I'm just going to copy. Actually, no, let me go back to VRF definition red. Go back to blue real quick too. And go back to the interface. And just copy this config back in. So there we go. So now that's going to be there. Now this guy is in a VRF. So now we're going to do a show VRF red. Now we have gig 1.46. If we show IP route, we have one less connection in there. Now if we were to do a ping VRF red to 46.0.0.4, we can ping, which is a good sign. So that means we have connectivity between 6 and 4. And the when you're dealing with OSPF, if you get us OSPF v3, we're not dealing with that, so we don't have to worry about the being at VRF aware by default. But the main thing with that is, if you put OSPF v3 in before you create the VRF, it's not going to catch it. You have to put the VRF in first, then create the OSPF process, and then drop it in, because then it'll become VRF aware. So the next thing we're going to do is we're going to go and show run interface gig 1.65, right? Keep forgetting. Yeah, 65. Config T interface gig 1.65. VRF forwarding is going to be blue, and we're just going to copy and paste this information back in. Now we're not going to be running IPv6 in this section, or at least in this scenario, but I spent a lot of time the other night getting all the addressing set up on 20 routers, so I feel like I've just bear with me. There's a method behind my madness. So that's how we get that going. So now what we're going to do is we're going to go to router 7 and do the same thing. So now what I get to do here is I actually get to go and type in show run section VRF, and I'm just going to copy and paste this information. I'm going to pull up Notepad, and I'm going to go something like this, and I'm going to copy this information out of here because I don't feel like typing it in twice. Let's just do this. So that's going to give us that, and then I can just sit there and tweak these as I go. So now we get to go to router 7. I get to exit out of here, and I get to just copy and paste this information into this guy. That gets us that. And then what I get to do now is I get to type in interface, or do show run. Let's see. Do show run interface gig 1.57. And I can type in interface gig 1.57. VRF forwarding is going to be red, and I get to just copy and paste this information in, and there we go. Now that's part of the piece. So what I'm going to do now is I'm just going to go to the other routers and get this operational. So now I just get to I'll tweak this as I go. Now the thing with this is, now let me bring this down and move it over. So we're going to be on let's squeeze this down just a little bit for you. So now that we've got 6 and 7 configured, 8, 9, 10, and 11 should go pretty straightforward because we have the Notepad document. Yay! So that's going to speed our process up here a little bit when we get into the configuration part of it, because then I can just start, detailing the configurations, making sure we have everything situated that we needed. So now what we're going to do is we're going to go in and start setting this up so that we can we're going to use 220. We're going to use the same route distinguisher. Alright, so what we're going to do is we're going to just tweak the name of the VRF to something else, so green. Since we're only going to be dealing with one VRF per router, I don't think it's going to be much of a much of a problem. So we're going to start on 10 and 11, and we're just going to exit out of here, exit out of here. Now we don't have to do that, but you know, so be it. And we're going to do Control C and paste, and then we're going to do the same thing on 11 and copy and paste. Now, one thing I'm not sure exactly if this is going to work when we actually go to do PE to PE routing is with the VPN v4 stuff, because I have the Send Community extended on the peer group, but I don't know if that applies to everything right now because I don't have 10.100 6.6 IBGP peers underneath this. So I'm not sure if it's actually going to be an umbrella command like this one is, because I actually have the configuration here set up and I had to pull in the peer group. But I guess we'll have to wait and see. So we're also going to go to 8 and 9 and we're going to type in just brown. There's a question: aren't you worried about the route distinguisher being different? I'm not, simply for the fact that I'll be able to play with that later on to get it operational, and because we're dealing with multiple VRFs in one router, because we got the same route target, and that's the main thing. Let me actually take a second. That's actually a really good question. I'm glad you brought that up. Because the fact that we're going to have the same route target, import, export values, that's actually how the VPN, the PE routers actually release and receive information. So if it receives an import for a VRF it doesn't have, it's not going to accept the update, because of the fact it's like, well, I don't have anything to give it to. So it's basically trying to receive a route for a routing table that doesn't exist. So if you're receiving information for a route target that you don't have a route target value for, so if you're not importing or exporting a particular route target, it's not going to work. So it's one of those things where you have to be careful when you're importing and exporting. If you don't have that route target configured, then it's not going to be listening for it. So so we're going to do brown, and we're just going to copy and paste this information into 8 and 9. So we'll go to 8 and right click and paste. So we don't actually have to exit out of it like I was saying a minute ago. You can do it from right there. So that configures all of that. And now we just have to go to, on 8, we're going to put this guy in a VRF and go and put this in the VRF, and we should be good to go. So on 9, we're going to do a do show run interface gig 1.199, and we're going to type in interface gig 1.199, and we're going to type in VRF forwarding is going to be VRF brown. I did configure it, right? Oh, haha. There we go. And I was like, what the heck? It's all the little things you don't anticipate happening that go, what? And you're like, oh, never mind. I know what that says. So we're going to do the same thing for here, interface gig 1.148. Or I should say show run interface gig 1.148. And since we're already here, type in VRF forwarding is brown. And we're just going to be able to copy this guy in. And there we go. So that's the VRF configuration. Well, actually I have to do 10 and 11 yet. So let's go to 10 and type in interface gig 1.112 show run interface gig 1.12 do show run, or do show IP interface brief, sorry. So 112. Oh, I don't have anything. Oh, I'm on the wrong router. That's why. I'm like, I was looking at 11, thinking I was looking at 11, but I'm actually on 10. So we're going to do nope. And we're going to go to, is that 103? And we're going to type in VRF forwarding is going to be green. And we're just going to copy and paste this information in. LDP4 identity cannot set VRF green identity. And the reason why that popped up is because of the fact that I'm not doing a it might be something goofy on this router because I wasn't able to get the EIGRP configuration to work. So don't worry about that for right now. I'm just going to copy this information in here, and we'll worry about that later on. Maybe that'll give us some troubleshooting to work on later. So the last one we're going to do is on 11. We're going to type in interface gig 1.112 and do show run interface gig 1.112, and then we're going to type in VRF definition or VRF forwarding is going to be green, and we get that down because we were running a protocol there, and there we go. So there we have it. So, and they notice how we have this additional syslog message where EIGRP is now down because we're not running an EIGRP VRF aware routing process right now. We're running an IPv4 global process. So now we're set up. So now that's all the VRFs have been applied to the interfaces. That would, to me, is the easy part. So creating a VRF is easy because it's basically just creating another routing table. No big deal. Then the route distinguisher and the route target, fairly straightforward. Route distinguisher makes the routes in the routing table unique. The route target allows you to take routes from that provider edge router and hand them off to another provider edge router, and take routes from that other provider edge router and import them into your provider edge for that particular VRF. So route targets just indicate who can exchange routes with who. Route distinguisher is the route making the route unique. So from there, I'm going to finish this video up, and we're going to go in and actually get our redistribution working. Now, we don't actually have to do that on 8 and 9. So let's go take a gander at what's going on with routers 8 and 9, because we were already running BGP. No, we weren't. I take that back. So I'm going to hold off on that. So we're not running BGP right now. We will be eventually running BGP between them, but not right now. So, and then we're going to actually, what's kind of cool, I was thinking this just as right now as I'm talking here. We're actually going to keep the MPLS configuration going for a little while, and we're going to run in and get some other things running like DMVPN, and then we'll do some multicast and some other stuff and go from there. So, but we're going to build upon this, but we'll change up how the MPLS core works with the partial mesh, the peer-to-peer. We've actually done peer-to-peer. When we did the technology labs or technology videos, we did peer-to-peer. Router 7 to router 8 on the 10 router topology I was working with, that was a peer-to-peer because it was one PE to another PE. The only time it got a little bit different is when we went to doing BGP as the provider edge to customer edge, and we did the site of origin. That's the only time it got a little bit different, where we did full mesh. So we're going to be doing a lot of VPN v4 route reflection coming up, because we're going to do a lot of load balancing and checking out how load share works. So that's it for this video. We'll get into the redistribution piece of it and actually getting routes to propagate and things like that. So I hope this has been informative for you, and I'd like to thank you for viewing.